Now that you know what an API is, let's start getting into the details of APIs. Three things happen in every API transaction. One, a request is made for something to be done. Two, a program is run to complete that request. And three, the program sends back a response. So this happens in every API transaction. Let's look at some examples of this. First example is a simple Google search from a computer. Here's my version of a computer. Here's the keyboard. Here's the monitor. On this monitor is the Google web search page. On this page is the search term box. Let's say we're searching for the term tuna. We click on search, the search button, and this sends a request to Google to search for the term tuna on the internet and give us back those results in the form of a web page or HTML. In this case, where is the program to run this search term? Because we know this program is not located on our computer. So this program is located in the URL. That's where this program is located. If we look at this URL, it starts with www.google.com. This means Google computer, right? So the request is made to a Google computer. We don't know where, but we know it's a Google computer. It's made to a program on this Google computer. Where is the program located on the Google computer? In this case, the program is located in a folder named Search. Just like we have folders in our computers. The Google computer has folders also. So it goes to /search, this being the Google computer, and this being the location where the search program is. We also have one more item. That's the search term tuna. In this case, we can add it to the URL in the form of a parameter. The start of parameters is question mark. And in this case, the parameter is Q for query. And we are querying on tuna. So this is all we need in our URL to get back the results. Try it. Put this in your browser. It works. Let's look at a second example. This example is a little more complex because we don't have an interface on a computer. The interface is located at the application. In this case, we're talking about an eBay order API, not the eBay web page, but the eBay order API, where you use a sandbox. If you don't remember this, go back to previous lectures where we talked about just this. So in this case, we have an eBay computer. The interface in the program is located on this computer. The order program is located in the buy folder, and within that folder, the order folder. So we need to send a request for an order, and we need to get a response back with confirmation of that order. In this case, the eBay computer is located at www.apix.sandbox.ebay.com. That's eBay Computer Sandbox. And our order program is located in the buy folder and the order folder within the by folder. So we go /by/order. So this is a little more complex, right? And generally when people talk about APIs, they're not talking about my first example of the Google search. They're talking about this, where you have to go to the application. It's more complex. These details are going to be explained to you next. So don't worry that you don't know these details. That's what this course is all about, to teach you these details. So exciting stuff, and you're on your way to being an API pro. Now that I've drawn what happens with the Google search on the whiteboard, let's look at what happens in actuality. So here is the Google page. This is my home page. And I'm going to do a Google search on the term tuna. What happens? The URL changed. It went to a Google computer. That's www.google.com. Then it went to the folder search within the Google computer. And then after that, it has parameters. Question mark is the start of parameters. And of all these parameters, and these parameters are separated by the ampersand, there is only one required parameter. The rest of them are not required. An example of a not required parameter is EI, which is the time, I believe, that the query was sent. Is this needed? No. So if we get rid of all the optional parameters and just include the search term and the parameter Q, what do we get? We get back the same page. So it went to the Google computer, the folder search where the search program is located, and searched on the term tuna using the parameter Q for the search term. What else happens on the Google homepage? What happens if we click on Gmail? That's not going to run a search, right? So what happens? We click on Gmail, and it tells us that it went to a Google computer, and in that Google computer, the folder Gmail, and then the folder About. And this ran the program after clicking Gmail, and this program sent back a web page to tell us about Gmail. Let's look at some other things on this Google web page. Let's click on images. What is this going to do? Oh, it gives us back a Google Images search. I don't think that these parameters are necessary, so let's see if we get rid of these, if we get the same thing. Yes, we get the same thing. So now we're going to search on the term tuna again, and we're going to get images. So how did we get these images? Well, let's look at the URL again. Google.com is the Google computer. Again, we have our search folder, which does the search function. And after that are parameters. Now, this parameter is to be matched, TBM, image search. So by using this parameter, the search program located in the search folder does an image search, to be matched image search. And it is searching on the term tuna. So let's get rid of everything other than the Q parameter. Click return. We get the same results. So this is the Google computer. This is the search folder within the Google computer. In this search folder is the search program. The search program takes in two parameters this time, not just one when we were doing our initial search, but two parameters. The first parameter is TBM, which means give us back images, and the second parameter is tuna, is Q equals tuna, Q being the search term. So image search on the term tuna, return, and we get images of tuna. So what happens if we get rid of the parameter ISCH? That means it will not do an image search. Take a guess what will happen. Maybe you guessed right. It will return what we had before, which is the web page for Tuna. It doesn't return images because it doesn't have that image search parameter in it. What is a mashup? Let's go to the internet and find out what a mashup is. I'm going to type in mashup definition and see what I get. Okay, so a mashup is a mixture or fusion of disparate elements. It looks like, in other words, we're taking different parts and making it into one. Let's look up another definition. Mashup is something created by combining elements. So yes, you use parts and you make one. Like if you're making soup, right? A mashup is when you take this part, that part, that part, then you make a mashup soup made of all kinds of different ingredients. So again, a mashup is from different parts, make one. Why am I telling this? So you can make great soup. No, I'm just kidding. We're talking about APIs here. So what is an API mashup? It means you're making one API from a bunch of other APIs. What's a great example of this? Travelocity. I use this site all the time. Let's take a look at Travelocity. Let's take a look at the Travelocity API. Here, what is the interface? Where are we telling the program to run? We're telling the program to run from this web page. We're giving this program data like where we're flying from, where we're flying to, what dates. We run the program, the P in API, by clicking on this search button. What is the application? The application is Travelocity. So again, the interface is this page right here. The program is run from this search button, and the application is Travelocity. Now, what happens if we put in, say, I don't know, Dallas, Texas, and we want to go to Chicago, and we want to go on these dates. Now, why is this Travelocity API a mashup? Because it's going to call the APIs from all the different airlines to find out their flight times and their prices. So let's see what happens when we click on search and start this API from this interface. Now you see it working. It's calling all the different APIs at the different airlines to get their flight times and prices per the requirements we said here. That's why it's a mashup. It's calling different APIs. Now the term mashup is not commonly used in the API world, but why did I want to tell you about it? Because I think it's a great idea, and this is the way a lot of things are going to be done in the future. APIs are going to be calling APIs that are going to be calling other APIs as this API world explodes.